Okay, so acids have a sour taste. So any type of food that you eat that has a sour taste, or drink that you will drink, will have a sour taste. Okay? Like, you guys eat sweet and sour chicken? Okay. Got a little sweet in there, a little sour in there. What else is sour that you eat or drink?
Sour Skittles.
What's that?
Sour Skittles.
Sour Skittles.
Yummy.
They probably have something citric. It's probably a citric acid, a powder that's concentrated. So when you eat it, okay, and then the sour kind of hits you back here, doesn't it? Okay? And so, what else is sour?
Warheads.
Warheads. What about, food, normal food that people eat that's a little bit more nutritious? Like,
Oranges.
yeah, oranges, lemonade. What's that?
Do like peppers have it?
I don't think so.
No. Oh, that's a kind of. This will make them burn so bad. Casing? No, that ain't right.
It's gasoline.
It's gasoline. Thanks, man. No, it's.
Chicken wings aren't sour.
Well, you can have sweet and sour
They're
chicken.
like,
You got green apples.
Green apples. Yep. Green apples would be definitely get those little apples off the tree that you get. Those make the best apple pies. Anything, those apples that are sour, they make really good apple pie.
Why
You
do
put-
they
Huh?
Why do they make good apple pie?
Because they're sour.
But when I eat apple pie, it's not sour.
Right, they put sugar in. So you got a sweet-sour combination. So a lot of foods are not just going to have just sweet. They're going to have combinations, flavors. So, okay, I'm not a foods teacher, so you'll have to take foods and figure that out. Okay. One definition of acids is anything that makes H plus ions. That is the traditional definition. That's what you learn in basic physical science, basic chemistry. We'll look at Thursday that there's another definition associated with acids, and it's a much better definition. And it includes H plus ions, but we don't really list the definition like that. So this is called a traditional definition of an acid. Anything that when you put it into a solution, there's H ions that will be broken off into H plus ions. And we also know that acids, if we have a metal, and there's some metals that won't react with H's, but there's a lot that do, that it will decompose the metal and react to make hydrogen gas. Used to be this thing, and not much anymore, because they've regulated industry that would put sulfur dioxide into the air. So we pay more for our consuming our energy because the energy companies, when they produce the energy that we use, have to filter out sulfur dioxide compounds, or sulfur dioxide gas. And if it gets in the air, it combines with water and it makes sulfurous acid, which is, it'd be a slight acidity to the acid. But in the Midwest, we don't have to worry about that because we don't have much population. It's back east is with the biggest thing that they have to worry about that because of all the cars and all the pollution that can take place. And but we don't really worry about that much. Any questions on properties of acids and bases? Okay? Or acids anyway. Bases. Bases. They're bitter. What type of food is bitter?
Crab apples.
There we go. I don't eat crab apples.
Well, right. Crab apples, if nobody's ever had them, you know they are bitter. Or any type of fruit that's not ripened yet. Have you ever had a banana that's not ripened? It's green.
Yes.
Okay? A lot of things when they ripen, they sweeten up. Okay? And then there's something in there that causes them to be bitter. Okay, what kind of drinks are bitter?
Cranberry juice.
Could be.
Yeah.
Could be. Coffee. Coffee is. Tea would be bitter. A lot of times people like to put sweetener in both of those so they can handle them. Okay? So, if you've ever had your mouth washed off with soap, then that would be bitter. Nobody in here's ever had a bar of soap like Ralphie on Christmas Story, right? Ralphie had to put the soap in there for so long because when he was out helping change the tire, helping Dad change the tire, okay? And then he blamed his buddy, right? And then the mom called the other mom and, what? What'd you say? What'd you say? Okay? Then you heard him getting spanked, whacked. Okay. They're slippery. Soap is slippery. Anytime you got a fitting or something that doesn't fit, there's friction involved, sometimes you can do is you get a little soap, a little bit of water, put it on whatever you're trying to fit together, and it's slippery. And then you can fit it, and it's going to be so bases are slippery. Okay? Any questions on those? So that's just some general information. The book will give a lot more information. It'll say, well, acids, it changes the indicator of acids, different colors. And we'll talk about that tomorrow, but it's not really something I want you to put down because acids and bases both change the colors of acid-base indicators. That's what they are. Like you guys know the pH paper, litmus paper. You test it to see if it's acidic. What color does it change to? Remember?
Yeah.
What color is it? Kind of
Yellow.
a pink. Pink. No, not
Yeah,
yellow.
we had no idea.
Okay? We did that in a lab where you had to put it in a solution to see if it's acidic or basic. And if it's basic, it's blue. Okay? It's called litmus paper. You have it in your drawer. In fact, you'll do it for a lab because you have to get a solution to acidic or basic for it to do a reaction. So they have that there, and then maybe one other thing, but these are the main things I want you to know. Okay? Now, what I'm going to do is I'm going to give you a sheet that has all right. When you look at naming acids, there are two types of acids. There are binary acids and there are oxy acids. Okay? So when you name acids, there's two types. The binary we know is two elements, H and one of the elements off the periodic table. H is in front. You should know that already, that if an H is out in front, it's probably indicating it's an acid, because we did some acid-base reactions called neutralization reactions that we did. Okay? So if it's an H out in front, other than water, other than hydrogen peroxide, it's an acid. There's binary acid. Binary would be like HCl. And there's a way to name acids to differentiate between the two. So there's so many different ways you could name acids, but they differentiate between the two. And if it's a binary acid, it always has a prefix of a hydro in front. Hydro. Knowing that it has a hydrogen ion there. The endings are always going to take that anion ending. That's a chloride, bromide, iodide, fluoride. They're going to make it IC. They're going to replace it. So it's ic acid. Alright? So it's going to be hydro, then the root word of the monoatomic ion, replace the IDE, and make it ic acid. Any questions on that?
So that'd be hydro.
Yeah, so that's just this would be a chloride. HCl would be like a chloride. The IDE comes off and makes it ic. Alright? Now, the oxy acids are a little bit more work. So if you guys have your polyatomic ion sheet out, you need to get that out so that you can figure these out. Polyatomic ion. Oh, by the way, that Tasty Freeze also, we put in a miniature golf course. And so we had a 9-hole miniature golf course in the back.
Who's paying on this?
My dad. So, growing up in the summertime, my brother, they didn't want in the, my brother Dave, they didn't want him in helping because he was more of a nuisance than a help. So they put him back in the, ahead of the miniature golf course, and then we would have miniature golf course tournaments like 27-hole, 36-hole tournaments all the time. So we got so good that 9-hole, we'd like shoot 11 or 12 on 9-hole. Because every one would be a hole-in-one because we knew where to hit it and how to hit it and that type of thing. So pretty competitive.
We just went with
I got a 12 on
Jessica
18.
won. She's pretty good.
Jessica won.
What'd you get?
They used to be on ESPN, believe it or not, I don't kid you. They used to have miniature golf course tournaments, and they would show it on ESPN.
My dad told me about that
And
one time.
if they didn't make a hole-in-one, it was just like, oh, he's lost. Because they would make hole-in-ones pretty much on every course.
He's lost.
It's like this far from the hole.
It's over. It's all over.
Okay. So, when we look at oxy acids, there's 2 ways to do it. Now, if you look at those endings, majority of those endings have ITE endings or ATE endings. Ates or ites. Ates or ites. So if it's an ite ending, it becomes an OUS ending, as an acid. Ites become us. Ates become ick. Maybe you can think and remember that if I ate it and it was icky. I don't know. Something that sticks in your head. I ate it and it was icky. Alright? Like a little kid. Icky, icky. Alright? So ite becomes us. And ate becomes ick. And so when you look these up, there's no hydro in front of these. So most students will put hydro in front of everything. When they do acids, they'll go, everything has a hydro in front of it. There's very few acids that have hydro in front of it. There's not very many binary acids. Most of them are oxy acids, and oxygen at the end. Okay? So if we look at HNO2 and look it up, we look the NO2 up and it's nitrite. Nitrite. So the ite becomes us and becomes nitrous acid. Nitrous acid. Where if we have HNO3, which is nitrate, that's nitric acid. Nitric acid. So questions on that. So we need to do a little practice, and we'll have our sheet down below, and we'll hit a couple of them, and then you'll do the rest. Okay? Any questions?
So like, how do you know if it's as a hydro or in front of
It's binary, doesn't have oxygen. Only 2 elements, H and another element. Okay, let's look at your list down below. Let's look at number 1. What kind of acid is number 1?
Hydroiodic,
Okay, what kind of acid is it though?
binary.
It's binary. So we got to put hydro in front of it. The iodide is not iodide anymore since it's an acid, an indicated acid. So it's iodic. All one word. Hydroiodic acid.
How do you spell that?
IODIC acid. Hydroiodic. Okay, so let's do one more. Let's do the H2S. And then I'll leave the other ones for you guys to practice. So H2S, that's a binary, right? 2 elements, no oxygen involved. So we look up sulfur, but it doesn't have an IDE ending. And so how do we treat that? So it would be like saying sulfuride, which doesn't exist, but if you were to replace the IDE ending, it'd be sulfuric acid. So it'd be hydrosulfuric acid. H2S is hydrosulfuric acid. Now, a lot of people will put hydrosulfic, okay? But they include the UR on that one. Phosphorus is the same way. If you have that one, it's phosphoric, it's not phosphorus.
I don't know how to spell it.
Okay? Hydro, then sulfur, like the words sulfur, and then IC acid. Okay? Now let's take a look at our examples of, so we did 1 and 4. So let's take a look at our examples of the endings that are oxy acids. Okay? So H2C2O4, number 3, you'd look up the C2O4. Got it? What's the name of C2O4? Oxalate. So, do we name it hydroxylic acid? No. It doesn't have hydro, only binary does. So that would be ATE becomes what? IC, right? So oxalic acid. Oxalic acid. Questions? Doesn't matter the number of hydrogens in front. Don't look at that because it has no play on the name that we're doing. So number 3 is oxalic acid. Let's do one more. Let's do H2SO3. So you look up SO3. What is it? Sulfide or sulfate? What is it? Sulfide. So that becomes OUS. So, and we'll include the UR when we name the acid. So that'd be sulfurous acid. Sulfurous acid. Sulfur, OUS. Okay? Now, what I'm going to do is I'm going to switch gears. I'm not going to name anymore, but what I'm going to do is I'm going to give you a couple examples where we have to write the formula from the name. Okay? So, we're going to do a couple examples where you name the formula from the name, and then I'll let you guys complete this front side and we can talk about your answers that you would have. Okay, so let's look at a couple examples here. I don't want to repeat myself here on these. So let's do this one. We're going to go ahead and give you a formula and we're going to name it. Oh, we want to write the formula though, right? I gotta go the other way. Sorry about that. Let's do this one. Cyanic acid. So what do you have to look for to write the formula correctly? So it's not cyanic on here, but what would it be?
Cyanate.
Cyanate. So find cyanate. So what's cyanate? OCN. Everybody see OCN? It's not OCD, but OCN. Alright? Nobody's in here at OCD, are they? You guys know what OCD is? I got a dog that's OCD.
About what?
He will go to the door, you open it, he'll go out, 1 minute later, he comes to the door, you open it, he comes around, and he eats his food. Every time. He won't go right to his food, he'll go to the door, you open it, out. Then he also, you can see lines in the lawn where they walk. He walks the same path all the time. And so you got a pathway in your lawn. Okay? Okay? So, this is what charge. OCN is what charge? -1. So how many hydrogens do we need? 1. So, it's HOCN. Any questions?
Oh, wait, no.
Okay? I'm gonna do one more. Okay? That you have to write the formula from the name. Okay? Here's one. We'll have to... I messed up again. Like I'm on that track of wanting to write the formula and not the name, so you gotta write the name. Okay, iodic acid. Okay, what would be iodic would be iodate. Okay? And iodate's IO3, right? And what charge is it? -1, so it's HIO3. Iodic acid. Alright, I'm going to let you guys practice that front side, and I'll go through the names of those. If you're done with the front side, do the back side. Do the back side.